April 14th. You know, that date might not jump out at you, but in the history of mathematics, it is a seriously special day. Any idea why?
Well, let's dive right in. It's pretty wild, but on this one single date, spread out across centuries and all over the globe, a few brilliant minds either came into the world or left it. And every single one of them left a mark that literally changed everything. So let's peel back the layers and meet them, one by one.
Okay, think of this timeline as our map. As we jump through history, we're going to place each person right here, building this incredible story of April 14th, piece by piece. Ready? Let's get started.
All right, first up, we're heading way back in time to India. Our mission? To uncover a secret that was hidden for centuries in the state of Kerala. This is one of those great stories about knowledge that was totally lost, and then, when no one was expecting it, found again.
So here's the big mystery. For the longest time, everyone just assumed calculus was invented in Europe, right? By guys like Newton and Leibniz in the 17th century. So how on earth did we find out that Indian mathematicians had already figured out some of its core ideas, like infinite series, hundreds of years before them?
The answer, believe it or not, comes down to this man, an English civil servant named Charles Whish. And the date that connects him to our story? He died on April 14th, 1833.
So picture this. Charles Whish is working in India, and he stumbles upon these ancient mathematical texts from what's known as the Kerala school. He starts looking through them and realizes, whoa, this stuff is incredible. He found concepts like infinite series, which is a total cornerstone of calculus. But when he brought his findings back to his European colleagues, they pretty much laughed him out of the room. They actually called it too ridiculous to deserve attention. But Whish didn't back down. He kept at it, proving that these incredible ideas came from India. He became the crucial bridge between this ancient genius and the Western world.
You know, his story is such a powerful reminder of a simple truth. Great ideas aren't just discovered once. A lot of the time, they're rediscovered, just waiting for the right person at the right time to shine a light on them again.
All right, let's keep this ball rolling. We are sticking with the same date, April 14th, but now we're going to jump forward in time to meet our next pioneer. Let's go back to our timeline and put him on the board. There we go. Charles Whish died 1833. See? The story of this one single day is already starting to build.
So we've just looked at ancient texts here on Earth. For our next story, let's look up. Way up. We're going to the stars to find a pattern that was hiding in plain sight, right on the surface of our own sun. Let me ask you a question that might sound a little weird. What in the world do some dark spots on the sun have to do with the GPS that gets you around every single day? They seem completely unrelated, right? Well, the connection is way more direct than you might think.
And the person who helps us connect those dots was born on, yep, you guessed it, April 14th, 1868. Her name was Annie Maunder.
Annie Maunder was this amazing astronomer and mathematician from Ireland. Working at the Royal Observatory, she had this job of just meticulously studying sunspots. And after tons of patient observation, she was the very first person to spot this incredible pattern. The sunspots actually move from the sun's poles down toward its equator, and they do it in a regular 11-year cycle. Now, this wasn't just some fun fact. It's absolutely fundamental for us today to predict things like solar flares, the kind of solar activity that can mess with our satellites, our power grids, and, yep, even your GPS.
I mean, her work is just so cool because it proves this powerful idea. Even something as massive and chaotic as the sun has a secret rhythm, a hidden pulse, if you just have the patience to watch it long enough.
Okay, we're still locked on April 14th, but now we're going to leap forward about 70 years. The world is changing fast, and a whole new kind of machine is about to arrive, one that's going to need a whole new kind of math.
So let's pop Annie Maunder onto our timeline. Her birth in 1868 makes the legacy of April 14th even stronger. Now, let's head into the modern age.
So our next stop brings us to the very beginning of the computer age. And I'm not talking about your laptop. We're talking about computers that filled up entire rooms but had less power than the calculator on your phone. Seriously. So think about it. How do you teach one of these clunky, room-sized machines to solve a really hard math problem, one with millions or even billions of steps? A computer back then wasn't smart. It was just a machine that could follow instructions really, really fast. You had to give it the right instructions. Well, the person who basically wrote the instruction manual for this was Charles Sims. He was another brilliant mind connected to our golden date, born on April 14th, 1937. Charles Sims was a total trailblazer.
He figured out how to use these early computers to do incredibly complex algebra. His big claim to fame is something called the Schreier-Sims algorithm. Now, it sounds super technical, but what it did was give those old computers a recipe to finally solve enormous problems in an abstract area of math called group theory. And why should you care? Because his work laid the foundation for the computer algebra systems we use today, and even for the cryptography that keeps your data secure online.
The way to think about it is this. Charles Sims didn't just use computers like a fancy calculator. He actually taught them a new language, the language of pure abstract math.
All right, for our final story, we're going to meet someone who went even bigger. He didn't just solve problems in one field of math, he created a whole new way for us to look at all of mathematics. Think about this for a second. You've got algebra over here, geometry over there, topology somewhere else. They all seem like they're speaking different languages. But what if you could create a sort of Google Translate for math, a universal language that could find the deep connections between all of them? The man who helped create that exact thing died on, you already know, April 14th, 2005. His name was Saunders Mac Lane, and he brings our story almost all the way to the present day. Saunders Mac Lane co-created something called category theory. Now, it's very abstract, but its goal is actually pretty simple. It's a powerful language for finding the fundamental structures and deep connections that link all these different fields of math together. This new way of thinking was absolutely revolutionary. It completely transformed modern math. And as if that wasn't enough, he also co-wrote a textbook on modern algebra that changed how the subject was taught to generations of students all over the world. And that's really his incredible legacy, isn't it? Saunders Mac Lane didn't just solve problems using the existing rules. He gave all mathematicians a brand new way to think about the rules themselves. So, let's take a step back. We've met 4 incredible people, all connected by this one single day. A historian in India, an astronomer in Ireland, and 2 pioneers of math and computing in America. What in the world connects them all? Take a look at our completed timeline. There they are, across more than 170 years. Whish, Maunder, Sims, and Mac Lane. When you really boil it all down, each one of them, in their own unique way, was asking the exact same fundamental question. What is the pattern hiding inside the chaos?
Whish found that pattern in ancient texts. Maunder found it on the sun. Sims taught a machine how to find it in numbers. And Mac Lane created a whole new language to describe it everywhere. So that just leaves one final question. This one's for you. What hidden patterns are all around